Okay, let's now see how we can make or implement simple service server and a simple service client in C++. So, if you remember on the command line interfaces tools, we got some examples of how a client and a server works. For a client to get a response, a server must be up and running. In that way, uh, the server started the communication and the client started the communication and the servers received that message and response in the terms that they can handle the package with the processing and to serve the service client with the response. So let's move to create a package for the service client. Let's see, ROS2 package create build type. In this case, we will be working on C++. So our package will be on a main CMake. If we want, we can create a license of Apache 2.0. The name of the package, let's put it C++ serve, and the dependencies, let's use some dependencies that will be explaining a little bit more. RCL CPP or standard dependency, and example interface. Okay, we will create a ROS2 package using C++ with the license Apache 2.0 called cpp underscore serve with dependencies of RCL CPP and example interfaces. So let's build it. Okay, here it is. Now let's move to cd cpp serve. Okay, we are there, but what I really want to explain you is what we will be doing here. We will be doing a service client and a server that add twins. For example, if we put A of the value of 2 and B of the value of 3, we send the information to the server and the server responds 5. That's all. So for this, I will show you the service message that we will be using is located on this location, cd opt ROS humble share example interfaces and serve. Okay, if you see here, there are some messages that we can use. There are those ideal files and other things, but let's just only concentrate on this one that we'll be using of the example interfaces, the add twins. Add twins, I think, what is? I think is one this response. Let's see. No, this is not add twins. Oh, this one, serve. Okay. Here, you separate always the request on the top side and the response on the bottom side. In this case, we will be using a simple message as it is. I just want to know before starting to move to the code what we'll be looking for. Remember, the part above is the query message or the request, and the part below is the response. It's just the structure of the message. You need to understand that, because in the future we will be building our own messages on our own um, server scripts for our client scripts for action and services. In this case, is services. So let's move on. The next thing that we need to do is to return to our default folder. Okay, and let's modify with gedit the package.xml. Okay, here as you remember, you can modify these parts about the maintainer and the description of the package. We will not do anything here. As we saw, the dependencies are called here over because we specify at the beginning of the creation of the package, so we don't need to put everything practically. So let's move back to the coding part. So here we will be looking at the source folder, and we will be creating a file. You can do it with Visual Studio Code or gedit or any kind of uh, uh, scripting application. If you want to change it to the highlight mode to be C++. Okay, I can see something here very different. Let's move on. So for example, here let's save it on the source source. Okay, with the name of, let's put it add to int server C++. Add to int server C++, because this is the server. Okay, let's explain the code here. On the main file, we are calling the initialization of the node. The node will be with the name add to int server, and for starting the service server, we need to specify which kind of interface about the message we're using. In this case, you remember, that's why we look back here, is the example interfaces server and then the add to ints. So in that case, we are using this type of service message. It will be a share pointer, and we got a name about this service message, and this will need to be creating a node service for the example interface add to ints with the name add to ints, and we will be calling the add message. So sorry, we'll be passing the function callback to the service server to be instantiated. Finally, we will be logging these things, and we will be logging the first message ready to add to it, and we will spin over the node. And if everything goes wrong, or we will shut down the interface, we will be cleaning everything without any issues, and that's all. On the callback, again, you need to specify that it's a constant standard share pointer of the type of message that you are receiving. In this case, we are receiving a request. Remember, we receive a request of the client name request, and the request remember the request got two message eight, sorry, two integers A and B. But let's keep it simple. Just remember that the request, there is a variable named request is in charge of the request part, and there is a variable of the response that is the response part. So the response get a variable named sum. In this case, is a pointer. That's why we reference it by these symbols. So the response sum here, the response sum is equal to the request variable A plus the request variable B. Remember, we upload the server and then receive something. In this case, it will be a message with the variables A and B. And finally, we will put the incoming request message, request A and request B, and also the response message. In this case, the sum of A and B that it was computed before. So after that, we need to modify the CMake list. So let's move and modify the CMake list. CMake list. We need to add the executables. Add executable server source. Add to ints server.c++, and we need to specify the dependencies about the server that is using RCL CPP, and also example interfaces. Let's see if it compiles when I do the call. But next we need to install in targets the server and the destination will be lib in the project name. Okay. So let's try to see if it compiles, and later we will try to show if we are receiving something to the server client and get a response about the server client. Let's see if it okay, I found the problem. Is one was the here and lib. So let's compile again. Okay, source install set hash, and below again source install set hash. Now ROS2 run cpp serve, and the name is server. Now it's okay. And now the server is ready to accept twins. Now let's see the message. This is the type of service message, and if we list the services, we see that there are service of add to service, and we can see also the types of service and the message inside these services. Now let's try to call with the command line interface to see if we can send something to our server here. ROS to service call add twins that is of type example. And we can specify A to be 2 and B to be 3. Let's see what happens. Okay, we got a response here. 2 plus 3 is 5. Let's see if it can accept floats. Probably not. We don't know. Let's see if it accepts floats. Maybe. Let's see. Okay, it accepts only integers because the message is add twins. Oh, what a wait. Okay, now this service server is working. Let's see if we can construct our service client. For our service client, we need to import a little bit different code. Let's try to see if we can get the service client node. Source, cd source, clear, ls, cd serve, ls, cd source, ls. Okay, here we'll be using nano, sudo nano add to ints client C++. Okay. And we will save it. Let's save it. Just open here. Client. Just to see this thing simple. We didn't explain the included headers, but you pretty understand why the header is in that way. And this one is the default one. We're using Chrono for timing, the standard library and memory. We're using the Chrono literals over the standard library, and we'll be instantiating everything over the main nodes. So the first thing is to start with initialization of the node with the argument counter and argument vector. And if the argument counter is different from 3, we will put a logger about the usage and we will return a 1. If not, we will continue the execution of the code and then we will instantiate a node called add twins client. This node will also has the client node to create a client with the type of message example interfaces server add twins, and it will be called add twins. Remember that our server is called in that way, add twins. So we will try to connect to that server. When we make the request here, we will be sending 2 integers over the request. It will be A and it will be B. Those are the first and the second arguments of the service client. If the service client is not present, we will wait over the service client, and if the RCLCPP message is okay or the ROS is running, sorry, if ROS is not running and the message service server, sorry, is not okay every second, will be interrupting the service server. Finally, we will put a message that it says the service is not available, and we'll wait again and again and again. When the service is ready to send values to the interface, we will need to send an asynchronous request and get a result. If we uh, get a result, we will print over the logger using our CLCPP, the sum, and finally, if something goes wrong, we will put that there is some problem with the service server. Okay, now we can add the executable to the CMake list. Let's move it. Add the executable, add executables, client, attends, client, and here client. Okay, that should work. Let's move again and compile our package. On line 29 on C++ on the CMake list. Line 29, client, here. Okay. And here too. Okay. Now let's move again and call our C++ service server. So ROS2 run C++ service server. Okay, our server is running, and for the client, we need to run ROS2 run C++ server and client, and we need to specify two arguments. Let's specify 1.1, sorry, and 2, and the sum is 3. So that completes the simple service server and the simple service client. You can check, for example, keep going and testing the service, or find the RQT graph here. Obviously, this will not be visible to you until you get everything working. Let's see something that we can see here. Clear, probably to service list. No, I think everything is covered here because we cannot do too much things. The service is running. We call the service via the command line interface, and also we call it using client library. So that's all. Let's move next to using Python, using simple service client and simple service server.